Hey guys, welcome back to my channel. My name is Satyajit Patnaik. Let's wait for people to join in. Just give 2 minutes and we'll quickly start. Okay, some people are joining in, so we already have more than 5 or 6 people on the chat box. Okay, let me quickly start with the introduction part and let people join in with the meanwhile. Uh, I'm not sure if you know about me or not, that I was also conducting such live webinars long back, like 6, 7 months back. And I have again restarted the same because from the past couple of months, I was not quite, I was really busy on Sundays, and because of which I was not able to do live webinars. But now we have started, and henceforth I'll be conducting such sessions as well. One more important announcement is coming up for the next Sunday. So next Sunday officially we are going live on multiple topics. I will be teaching certain topics on, I don't know what the topics are. I'll not be disclosing it right now, so wait till the end of the stream so that I will reveal what's going to be taught from the next Sunday. People who are following me on LinkedIn probably know the topic, but I'll keep it open. I'll probably discuss that in some minutes. Now, talking about today's session. Okay, hi everybody. So for today's session, we have a guest. I'll definitely add him to the video as well in a couple of minutes. So his name is Saurav Agarwal. He's currently working as senior solution architect at NVIDIA, and he's basically, he knows everything, basically data engineering, big data, machine learning, AI. So he's kind of a person who knows end to end data science and analytics and engineering part. So I have with me Saurav. And one more other introduction about Saurav is also that we know each other from the past 15 years. So we started together, my college days, we started together. So it's almost been 15 years. We know each other. So he's a guest to all of you, but not to me. So let me add Saurav and we'll quickly have a small introduction. And basically, today's agenda is going to be on data engineering. As the topic says, everything about data engineering. So, no such agenda, but in case you have any questions related to anything, related to what tools we need, what not, and all those things, you can simply ask your questions on the chat box. So, I invite Saurav. Hi, Saurav.
Hey, hi everyone. Good evening in India, and good morning, good afternoon for any other time zone people. It's an honor to join Satyajit's uh, YouTube channel, which has grown a lot in recent days. Yeah.
Okay, thank you, Saurabh. So, okay, so we'll quickly start with the questions that I have. And in the meanwhile, I'll give some time to the chat to digest what's going on, and then the chat can also start asking questions. I'm sure the chat box is on for subscribers. So if you haven't subscribed the channel, please subscribe. Saurabh also has his own channel for data engineering. He's not super active there, but he do have end-to-end playlists on multiple topics as well. I might not have his link in the description right now, but you can simply search his name on YouTube. You'll definitely get it. Okay, and at the end of the video, we'll also provide his channel link in the description as well. So the first question to you, Saurabh, will be a very basic question. You can probably start with what exactly is data engineering and what is the.
So, thanks, Satyajit, for asking that question. First of all, there are a lot of jargons going on in the industry about data or AI or ML or data science, right? So, data engineering is one such jargon which has been trending in the last few, maybe couple of years. Before that, there was ETL, I mean, big data. Before that, there was ETL. So days pass by, but the same thing gets modernized with the modern stack and gets renamed to a new name, right? But at the end of the day, data engineering is all about processing of the data from one source or many sources to the destination by doing the extraction, transformation, loading, and all the analytics behind it. So all kind of data related activities apart from ML or AI is nothing but data engineering. So you can call it data preparation is a part of data engineering, data wrangling is a part of data engineering, data processing, data transformation, all and everything is a part of data engineering. So there is no such point definition of data engineering, but yes, when you hear about all these terms about data uh, uh, going from one place to other, that's data engineering, right?
Great,
And
great.
yeah, coming to your second question, Satyajit. So the second question you talked about is career path, right? So there is no set career path that everyone has to follow this particular path. Like in software development, they have SD 1, 2, 3. So definitely there are companies with start with D1, D2, data engineer 3, data engineer 4, and then maybe engineering manager and so on and so forth. But it is not mandatory as such. So what I would say is, maybe you can say that initial 0 to 2 years, what you can do is you can learn the basic of data. I mean, understanding data, SQL, and SQL querying of the data, basic processing of the data using normal shell scripting or Python scripting. So you should focus on that particular aspect of data by using the most native tools like SQL or Python to process the data. And that kind of person is still a data engineer, but it's a junior data engineer role, right? So then it comes to senior data engineer role. So having said that, it's not mandatory that junior data engineer role should not know the advanced stack, but they should focus on these two aspects of data engineering rather than just going and learning hundred of different technologies, right? But when you become when more and more senior, like become a senior data engineer or a lead data engineer, you have to focus on creating or expanding your knowledge about data, processing data using various latest and greatest. So you can think of, suppose you have 10 GB data, so or maybe 1 MB data, you can process it using a Python code, a normal Python code, or a SQL query on a RDBMS kind of system, right? But when you get more and more experience, you will also be dealing with a lot of voluminous data. That means it can go up to maybe terabytes, gigabyte, multi petabyte scale as well, right? So for those scenarios, you cannot use a normal Python or SQL kind of interfaces, right? So you have to use advanced tools like we call it the big data tools, where you can not only deal with the volume aspect of it, but also the unstructuredness or real time data, like coming from devices like IoT devices or Fitbit kind of devices, right? So all that needs a specialized stack. So that specialized stack nowadays, the most famous part of the stack is Spark. Okay, so there was Hadoop, but Hadoop is now also modernized, and we use mostly Spark for data processing, and maybe cloud data storage or HDFS data storage for data storage purposes for the huge volume of data and unstructured data. So these kind of tools, if you know, then yes, you can very well focus on data engineering aspect of it in a larger, broader manner. So, and then when you lead a team of that, you become a lead data engineer, and then after that, you can become an architect. So, like I am an architect right now, a senior architect working at NVIDIA. So you can become a senior data architect or a senior data architect, or you can go to the engineering manager role. So engineering manager role is data engineering manager will manage a team, though he will also be a people manager, but at the end of the day, is not expected to just manage people but also manage the projects, that okay, the delivery or the code or whatever is being done is following the latest state of the art technical tools and governance practices or not, right? And then yeah, after that, once you become a data engineering manager or an architect, it is the same, that if you want to get into further roles about leadership, right? So you can become, say, a kind of a senior manager, a senior architect, and then maybe become someday a CTO as well, right? So the all the way, both streams of management and architecture merges to become a CTO or a CEO kind of person, right? So it all depends upon your interest. There is no set path for that. So this is the usual path which people follow nowadays, and doesn't matter if you're working in a product company or a services company. This should be your focus of career path.
Great, great, great. I see a lot of questions coming up in the chat box, so we'll keep that uh, for hold right now. Let me finish my questions because
Sure.
I'm on priority, and then I'll be taking your questions, chat. So my second question is a very generic question. Uh, Most of the people are asking this question, that if I'm into data science or I'm already into data analytics, I want to learn data engineering, what should be my learning path? What tools do I need to learn? How much time do I need to invest in the learning path and all those things?
Right. So I think part of the question, or almost the entire question, I have already answered in my previous, because I combined the learning path with the career path. That hand in hand, the learning path and career path will go hand in hand. Like I said, basics, you should focus on Python
Yeah,
programming or Java programming, and SQL, writing SQL queries. That's the base, fundamental you should be clear on before deep diving. And then you can go to tools like Spark, Kafka, HBase, or any kind of NoSQL like MongoDB, or cloud-based NoSQL databases, Cassandra, or similar Cosmos DB, or DynamoDB, and similar
yeah,
things, right? So what I would lay focus on is, definitely after you are very much expert in SQL and Python, or any kind of programming language, then you should go and learn Spark, because that's the most important. If you see 80% of the work or 80% of the interview question nowadays are based on Spark only. And then Spark, apart from Spark, you need some real time stack also. So Kafka is one of that. So Kafka, and then Flink, but Flink is not that important. So Spark, because Spark also covers the batch part of it and streaming part of it, so it can work with Kafka itself. So if you want to prioritize Spark, Kafka, and then one NoSQL database, it can be anything. MongoDB is the most popular one, but you can also go with any other like Cassandra, HBase, etc., etc. Right? So this should be your focus of learning, and then there is no limit. I mean, there are tons of tools for each real-time processing, batch processing, storage. You can also focus on learning one cloud at least. So the most easy to learn cloud, I would say, is GCP, because it provides a lot of free credits for people who don't have access, right? So, but you need a credit card for sure, but that doesn't mean you will get charged for it. You get 3 months of free, I think 15,000 or 25,000 amount, which you
yeah,
can very well use to create Hadoop clusters and practice on top of it.
correct, correct,
So any cloud is fine. So that should be your end-to-end learning path, to be
correct.
precise. Yeah. Yeah.
Yeah, my next question was related to same, that which cloud should people prioritize, but you already answered GCP. So yeah, I
Yes.
mean we already got an answer to that. So my next
So
question to the,
just clarifying one thing, Satyajit. So GCP is not from the market perspective.
yeah,
Definitely, if you see from the market perspective, it is AWS for sure. That most of the companies, like 60% market share is of AWS. But AWS you cannot do hands-on, because the free tier does not allow you to create EMR clusters, right? Spark
yeah,
clusters. So that becomes a bit difficult. So Databricks is something which you can try. There are periodic free trainings given by Databricks guys themselves, so you can try that. But yes, AWS is the most used in the and most easy to learn is GCP. To
yeah,
clarify.
yeah. So ease of understanding wise, GCP is something which people can get started with, at least get
Yes.
the hands on, because it's not mandatory to learn each and every cloud architecture. Even if you are learning one, that should be fine. But yeah, AWS simply you cannot practice because of the inaccessibility, and it's chargeable, right? So that's also
Yes.
one more thing.
Yes.
Okay. Keep questioning, guys. I'm already noting all these questions of yours. I'll probably ask my last question for the time being. I do have like 8 to 9 questions. I'll probably ask my last question and then pick one of the questions from the chat. So my next question to you, Saurabh, will be: what is the role of data engineering in enterprise data architecture?
Yeah. So when we talk about enterprise data architecture, as I was telling previously, when you asked the first question or before that itself, that what is data engineering? I explained that data engineering is flowing of the data from source to target. So, so if you talk about data architecture of an organization, it's nothing but the end-to-end data engineering part of it itself. But sometimes in the data architecture of our organization, we also include the AI, ML, or the visualization part of it. So these three things: AI, ML, visualization, uh, and then there is DevOps, security. So all these aspects of the data architecture are not included in data engineering. Data engineering just deals with flowing of the data, how to extract it to the best possible way, how to transform it the best possible way, how to serve it in the best possible way, whether it is batch or streaming, whether it is real time or slow coming data. So all that deals with the data engineering. But anything apart from that, be it ML, AI, on top of the data already prepared by the data engineering process, is not a part of the data engineering part of it. But yes, it can be a part of the data architecture, because that also has a lot of data. And then when we talk about data architecture, we also talk about the supporting architecture, what will be the infrastructure, whether you will use a CPU or a GPU, what kind of hard disk, whether you will use SSD or NV, or a normal old style disk, or whether you will use some kind of pre like pre-created DevOps pipelines on the cloud, or you will use a custom pipeline using Jenkins or similar tools, right? So all these aspects also tie in together to create the end-to-end data architecture of the organization, which is not essentially data engineering.
Got it. Got it. Okay. Okay. So I'll pick my first question from the chat box. Okay. Pranav is asking, when you refer to advanced analytics, what exactly is meant?
Yeah. So advanced analytics, it's written in my, I think, job name, right? Big data and advanced analytics, right? So advanced analytics is nothing but when we talk about ML and AI, right? So either we can call it ML AI, or we can call it advanced analytics, because normal analytics involve like SQL, Power BI, and similar tools. So if you talk about normal data analytics, it includes only historical data analytics, right? That descriptive analytics. But when you talk about predictive analytics, when you talk about prescriptive analytics, that how you can predict a churn of an organization, churn of customers, churn of employees, if you want to predict that. So the ML part of it basically, so that ML AI part, if you include that, that becomes advanced analytics, right? So I think that's the brief answer for that.
Yes. One more question is that, okay. Ronak is asking, I'm confused between big data and data science, which one to go with. Wants to switch from a production support to another domain, but confused with these two, big data versus data science.
Right. So a lot of people have this questions that they want to transition from any other career to this data career path, and both the career path of data engineering and data science seems to be lucrative. You must be hearing multiple lakhs of salaries. This guy has got this much salary and all that stuff, right? That is the prime motivation factor. But let me clarify that there is no salary differences between salary structure of data engineering person or data scientist, unless until you become a very proficient data scientist, like with a PhD scholar or something like that. Then also in the data engineering, you can think of a person like who works for Google. So Google data engineer gets 1 crores of rupees, right? So you cannot compare the salary structure that okay, this will be more salary, this will get more salary to me, or that will get more salary. So what you have to focus on, what you are more interested in, whether you are more interested in mathematical and statistical aspects of the data, or whether you are more interested in processing the data, that engineering the data, basically how you can extract the data better, how you can transform the data better, how you can serve the data better. If you are focused, if you are more interested in that, then definitely big data is the or data engineering is the way forward. But if you are interested more in the use case aspect of it, that I want to predict the churn, I don't want to deal with data a lot, but I just want to implement some kind of prediction or some kind of AI on top of it, right? So think about your interest rather than thinking about any other thing in the market demand. Both have the similar market demand, though many will contradict that, but I would, based on my experience, and if you go on LinkedIn, you search for data engineer jobs, or you go on LinkedIn and search for data science job, you will not get much of a difference in the numbers, right? So that's what my focus, or my suggestion would be, that focus on your interest rather than any other things.
Yeah, good point, Saurav. Yes, I would like to add one small point as well. Data engineers earn little bit more than data scientists, but yeah, just joking.
Yeah.
Okay, honestly speaking, at least here the market in Hong Kong is quite, I would say, data engineers. There are lots of opening right now in Hong Kong, and because of some visa restrictions and all those things, uh, talents are also going away from Hong Kong right now. But I can see there's a lot of demand in data engineering, not only in Hong Kong, in Singapore, in most of the parts of the world right now, and it's one area which people haven't thought about right now. So the number of data engineering uh, enthusiasts are kind of less as compared to data science, but both are equally good. And in fact, data engineering is better than data science as well. So my next question to you, Saurav, will be, is, because I have minimal to like intermediate or less than that knowledge on the data engineering part, because I have also done some uh, engineering work, but of course you are like already working in that industry from 10 years. So my question to you will be, how difficult is it for a non-technical guy who comes from purely non-technical background without any prior programming knowledge, how difficult for him is to know or get into data engineering? Is it possible?
Yeah. So see, if anyone is non-programming or non-technical person, so getting into anything into IT will be a big jump for them, right? A big kind of a effort taking process, right? So it's not that you will just play around like a game, right? Point and click, you will open the browser. None of the IT technologies which pay well, you do that for sure. Anything, be it data science, data engineering, or anything related to data, uh, involves some sort of coding, some sort of SQL querying, some sort of understanding the scalability, right? So coding, and as I told you, focus on the fundamentals. Once you are very focused on the fundamentals, then you won't face a big uphill task to learn data engineering. So if you are okay with the fundamentals, learning data engineering tools and technologies will not take much of a time. So yeah, it's I have seen myself hundreds of people moving from non-technical to technical. So it's not a big deal. People have done that. Non-technical people, I mean non-IIT people, non even I have seen some non engineering background people also have done that, right? Like BSc people, MSc people, something like that, right? So you have to focus on the fundamentals. Rest everything is a process. Definitely it will not happen overnight. You have to be consistent. It will take some time, maybe 6 months, maybe 1 year for some of the people. But yes, if you regularly give your efforts, within no time you will see growing in this industry.
Great, great. Yeah. Okay. So the answer is it's possible. Okay. Uh, my next official question was, what is the difference between data science and data engineering, which is already covered. So I'll try to skip that and probably go to the next question.
We
Uh,
can take some question from the comments, maybe, if
maybe we
it's.
can take it from the comment, from the chat box as well.
Yeah. So there is one
Uh,
question from Rishi that in big data job DSA is required,
yes, I'll
right?
answer that.
So see, let's take that question because it's the most frequently asked question, that whether data structure algorithm knowledge is mandatory. See, definitely data structure algorithm knowledge is good, and a very fundamental skill to have to crack FANG kind of companies, or nowadays they are called MANG, right? Because most of the product companies, they have one round of data structure algorithm, right? As simple as maybe array processing or linked list, or some sort of tree, right? So definitely it is not mandatory, but it is very good to have. Though it is not the end of the road. If you don't know DSA or you are facing difficulties in understanding and learning DSA, you can focus on basic programming. I mean, basic Python programming, SQL programming, because companies like I've personally experienced Amazon, right? Amazon is a company which is a part of the bank company where data engineer role, they don't have data structure algorithm round. They have a SQL round, complex SQL
Mm.
round. So like these, there are many companies who don't have even SQL round. Also, they have big data tech stack round and system design round. So they focus on the system design. How will you design an architecture of a data pipeline, and how would you implement that, and what projects you have done in the past. Maybe they will ask you to write Spark code rather than data structure algorithm code. But yes, some sort of coding is required. You cannot do away with coding and say I want to become a data engineer for sure.
Okay, great. So many questions. Let me take one question again from the chat box. Let's try to answer everything from the chat and then I'll go back to my questions.
Sure.
Okay, we already covered what is the difference between big data and data science. Can we do project using Hadoop, Sqoop, and Hive? If yes, can you please suggest some sources for projects?
Yeah, definitely. You can do Hadoop, Sqoop, Hive, and also I would recommend to use Spark also, because that's, as I told multiple times, that Spark is one of the important tools to learn and do hands-on with, right? So where to learn? I have YouTube channel where I put few projects already there. So maybe Satyajit, I will share with you after this session, and you can put it in the description of the video and also comment, so they can go to that particular video and learn. Yeah.
Yes, we'll do that. So I'll definitely leave Saurav's link in the description below, but you can remember his name for the timing. If you want to subscribe right now, you can. The next question is from Shubham. Is asking, I think it's already covered. How much programming is
Yeah,
involved in
yeah.
data engineering? It's already covered. So we'll move on to the next question, which is by Sumit. Hi Saurav, how is NVIDIA exploring a move to a petascale architecture as part of the road to exascale for their key high performance computing systems data centers?
Okay. So, see, first of all, Sumit, I would like to say that this is not a data engineering question as such. So, though I work for NVIDIA, so I can tell at a high level, not going deep into the answers for everyone's betterment. So, and time. So, yes, NVIDIA is exploring petascale architecture, and it has already implemented with multiple supercomputing centers it has, right? So it is not that we have one supercomputing. We have across the world many supercomputing centers where we have already proven that we can do petascale architecture and implementation around that. Also, we have in India itself work with the government of India, especially in the NSM, to implement multiple HPC for them, right? So it's like many things are already done, and exploring to petascale architecture is not something which we are exploring. We have already implemented that, to be precise.
Great. Okay, so the next question is how important is Scala? So we Scala is already discussed, but if you want to give some pointers on this, maybe.
Yes. So, learning about data engineering on Spark. So we all know that Spark as an open source project is built on Scala. So the most preferred in terms of say performance, or the native ability of doing the processing, right? We call it robustness. Scala is the most robust programming language to be used with Spark. Uh, However, if at all you are not comfortable with object oriented programming, or you're not comfortable with Scala, it's very new to learn, or you already know Python, so there is no need of learning any additional programming language just for the sake of it, right? If you get a job and in that job the project is being implemented in Scala, then yes, maybe you can focus on Scala. But suppose you are learning something new, right? Then learning Scala, Python, Java, all the three programming languages not needed. So most easy is Python, and there are hundreds of requirements of PySpark data engineers rather than Scala. So Scala, yes, there are certain companies, specific companies who require Scala as a skill, but these are they are countable in numbers, right? So most of them are okay with any either in any programming language or PySpark. So I would say it is important, it is native, it is robust, but at the end of the day, it is not mandatory to learn Scala to learn data engineering or Spark.
Yeah. So the next question I'll take from me, and then we'll jump into the chat. So my next question from my side was again, how is the market of data engineering right now in India and abroad? You have already somehow covered about this thing. So I'll
Yeah.
jump on to the next part, which is, as per you, what would be an ideal data architecture?
Okay. So I think that also okay. Let me clarify that in detail now. So ideal data architecture is something which serves the business requirement, right? It should not be that okay, today I'm learning big data, I'm learning Spark streaming, I'm learning Kafka, I'm learning SQL, I'm learning uh, all the technologies. So I should be able to implement all the technologies in one project. So that doesn't happen actually. It all depends on business requirements. If at all you want to do it, you can create your own data. Like there are hundreds of open source data sets available. You can very well create one data set for streaming data, one data set for batch data, which way you can flow from source to target. You can do some data ingestion, data preparation, uh, data cleansing, data quality, and then data transformation, and then data visualization. So all these steps in the sequence I mentioned, if you can do for both real time and batch data with tools like Sqoop, tools like Spark, tools like Druid, if you can involve all these tools, NoSQL databases like HBase or MongoDB, then it is the best architecture. I mean, it is the most wide architecture you can use. But at the end of the day, when you look from the company perspective, they are not concerned about whether you are using Kafka, whether you are using Spark. They are concerned about that how stable is the system, how performant is the system, how well easy to operate is the system, how cheap is the system. So you have to focus on these 4 to 5 aspects while working on company projects rather than thinking about your ideal architecture. But yes, if you want to do it, you can. Nobody is stopping you. Everything is available. As I said, open source data sets are available. If you don't want to use that, you want to create your own data set, there are tools to create dummy data. So you can use dummy data generator. You can process. You can use GCP credits to create Spark clusters and process it and do the end-to-end project also.
Great. I see a question from Ronak again. I think it's already covered somehow that if we go with big data, then having a knowledge of Python is sufficient, or we need
Yeah,
Java
so
as well. I
same
think
answer about Scala. Yes.
it's already covered. So, okay. So one question would be, I'm switching from, I think we covered this question as well, but let me read it out. I want to switch. Shubham is asking again, I want to switch from production support to development. I'm confused between data engineering and backend. I like programming, which will be better to go.
So both data engineering and backend development involves coding, but backend development involves more coding. And again, it lies on your interest whether you want to create microservices, APIs, and similar things more, and kind of a scalable application-based architecture, or coding more, or whether your focus is or interest is more on the data aspect of it. So based on that, both careers are lucrative. Both from salary perspective, again, it's the same comparative thing. Uh, so yes, that doesn't matter if you like coding or not. Both involves coding. But it matters that what you are more interested in, whether application based architecture or data based architectures. Based on that, you have to choose the field.
Great. Again, one of these questions asked by Shikhar, and it was also part of my questions as well. What are the most important topics which are mostly asked in data engineering interviews in big MNCs? Maybe you can divide the answer into different segments, freshers,
Yes.
and then mid-level,
Okay.
and then
No, rather than segmenting on freshers, I will segment on the rounds. And
okay.
the only difference is that the senior you go, there are more and more rounds rather than differences in the pattern of the interviews. Okay,
Okay.
so what is the pattern of the interview is you start with the basic programming ground where they ask you programming SQL, write some complex SQL query. They give you scenarios that okay, this is the source kind of table, and this is the destination kind of table I want. Write a SQL query, or this is the scenario I have. Write a Python code or any kind of code. If it's a product-based company or startup, they might also ask you some data structure algorithm kind of questions. Apart from that, if you've cleared that, there is a big data stack round, right? The big data stack round, they focus on anything and everything about Spark, uh, maybe storage like HDFS or ADLS or S3, similar if you are working on cloud. If you are working on, say, real-time data, they will ask you about Kafka, Spark streaming, and similar things, right? And also, if you have worked around NoSQL, then maybe that NoSQL technology. So these are the 5, 6 things they will ask you in the big data stack round. And then, if you are a little bit senior or depends on the company, they might also have a system design or architecture round. So they'll give you a scenario that you this is a Uber application, like a Uber booking company, cab booking company like Uber, and you have to design the backend data architecture for it for this use cases to create reports and all. So you have to design the end-to-end data flow that this application. There are two types of application. The data will flow from here to here, from API to ingestion layer, from ingestion to SDFS, then process it in Spark, and then so on and so forth, right? So these are the kind of questions you will get in the system design round, designing various backend or data architecture for uh, apps, large apps or companies which you already might know about, right? So apart from that, there might be managerial round or HR round, which is common for everyone. And there can be multiple rounds. It depends on the seniority. Multiple tech rounds, multiple coding rounds, because tech and coding is the most asked and the most difficult to prepare. All other rounds are relatively easier to prepare, right? So based on that, you will.
Yeah.
But yeah, this is the focus you should have.
Yes. Okay. Okay. Let me see. Anybody has any other questions? So Sumit wants to tell that he really likes your channel, Saurav.
Thank you.
Even I like Saurav's channels a lot. I keep pushing him upload videos, but he's quite busy with his time schedule and all those things. But
Yeah.
we'll see more videos from his channel.
Hopefully, yeah, if I get time. Sure.
Yeah. Rishi is asking nothing related to data engineering,
It's
but
more
it's
for you. Yeah.
a question for me to answer. Job opportunities for Power BI versus Tableau. I would say equal amount of job opportunities in both, at least in India. Community-wise, Power BI's community is way stronger, which makes your life easier in learning Power BI better as compared to Tableau. But coming into Asian Pacific area, or Southeast Asian Pacific area, or Southeast Asia area like Japan, Korea, or these countries, or Hong Kong, even in Singapore, Power BI is having better job opportunities as Tableau. But in India, it's still Tableau is still above or better than Power BI, but Power BI is coming up. Okay. Next question. Guys, let's keep this call limited to data engineering topics because we don't get time, Saurav's time quite often. So let's utilize him, ask as much questions related to data engineering. One very good question by Sajjan Parida is many companies are going cloud only for big data, like his current company. How do you see the usage of on-prem frameworks in future, and how can he keeps his knowledge up to date on premises?
Yeah, that's a really good question that many companies are focusing on cloud first approach. even large companies, or whether it is a startup or a small company. So because the agility the cloud gives to try out new things, and also with the limited cost and kind of flexible cost pricing strategy it has, right? That okay, you want to try new things, you don't have to buy thousands of dollars of servers. You first try it on cloud. If it works, all fine. You take multiple such instances and work on that. So but at the same time, there are some concerns on the cloud around the security aspect of it, around the management aspect of it. The biggest is the security for sure. That how we can create a firewall, how we can protect client, I mean companies very private and secret data. If that's exposed in the cloud, there's a high chance, if not external hackers, there might be some conflict of interest from the cloud companies themselves to have a leak of the data and access their data, right? So because of all this, the on-premise, especially for the banking and telecom world, is still alive. They focus a lot on on-premise thing. So hence, definitely, it's not a case that on-premise is not there. But at the end of the day, on-prem or versus cloud, from the perspective of a data engineer, is not a lot, because here also you have to write a Spark code. There also you have to write a Spark code. Here also you have to write a Kafka kind of producer and consumer. There also you have to write Kafka producer consumer. So focus on the fundamentals, focus on the open source technologies aspect to it, rather than focusing on learning only cloud proprietary technologies. When you work with that, you see that all these cloud technologies, most of them, at least 80% of them, are just a wrapper or an abstract layer on top of this open source technologies, right? So if you know Databricks is a layer on top of Spark. If you know say something like Event Hub, it is a layer on top of Kafka. So similarly, all these technologies are nothing but layer on top of open source Apache or related projects, which you should focus on. In that way, you should be good with both on-premise or cloud-based systems.
Great, great. So, anybody has any other questions? Pranav, you're asking something again, not relevant to data engineering, so we'll probably not answer. Maybe you can get in touch with me on LinkedIn. I'll try to answer it. One question from Rishi would be, is MapReduce important for big data? However, Saurav has already covered this, but yes, sir, if you want to.
No, I think MapReduce is not that important, because Spark has almost replaced MapReduce everywhere. So, because of the in-memory computing capability Spark gives, as compared to the disk-based computing capability of MapReduce, Spark has almost 99% replaced MapReduce processing all over the world. So, yes, it's not mandatory. Though, when you first time learn about big data, you should understand at a high level that how MapReduce works, because that is how similarly all the distributed technologies work, right? So you should understand the paradigm of MapReduce, rather than you don't have to code a MapReduce job and implement it yourself.
Great. Any more questions, guys? I don't see any questions, and even I don't see the need of my questions to be asked, because somehow all these questions are already covered. Some repetitive questions are there, but I'll not ask that. We'll keep this call open for maybe a few more minutes, and start. You can ask other questions if you have. Uh, in the meanwhile, let them reply on the chat box. Sort of, how difficult is it to create or demonstrate a small big data project? How much time will it take if we go for a live session? Just asking.
Yeah, from the project perspective, if you want to implement and show it in a live session, definitely it will take a lot of time, because data engineering project is not such that okay, in one notebook you can cover. Because suppose if you want to do a ML project, you might be able to cover everything in one notebook: the data pre-processing, data model creation, and some kind of inferencing, hyperparameter optimization. But from the data engineering aspect, you have to write, say, as I was telling, if it's a real time, you have to write Kafka Spark code, Kafka producer consumer code. You have to write Spark processing code. You have to also write some kind of Spark SQL code. You have to write some sort of NoSQL code, and then you have to marry that all together using some orchestration tool like Airflow, right? That how you'll schedule it to run every now and then to flow the data. So all this is a bit complex. So covering end to end, though I have put some of the projects in my channel which cover end to end, but I have not implemented on the go in that. So I have shared the code, I have shared the use case, I have shared the explanation of the project, but how to execute it. But writing the code on the go is definitely it's a very complex thing to do in a even few hours. Even yes, if we sit for say hours and hours together, maybe for 5 days, every day 6-7 hours, then you might be it might be possible to code a simple project end to end.
Yeah. Okay, that makes sense. One question from Shikhar again is, however, I already answered this question in one of my previous videos, but maybe from your side, what do you want to answer this? What is the difference between ETL and ELT?
So from ETL and ELT, the only difference is how you want to design your pipeline. Whether you want to transform the data first or whether you want to load the data first and then transform it. So what happens is there were previously there was some tool like Informatica which used to do both of these ETL or ELT with Teradata kind of databases, but nowadays it has been replaced by Spark and HDFS and all that stuff, right? So suppose if you are extracting the data from the source, and before you are loading the data to the target in Spark process, in the extraction process, you are also transforming it, right? Then you call it, okay, extract, transform and load. Okay, but if you are first extracting the data and then loading the data to the target SDFS or wherever, and then you are transforming it, right? So most of the data lake kind of projects follow the ELT approach nowadays, because they first land the data as is in the raw layer of the data lake, and then we load the data again to the Spark job and transform it and then write it back, right? So nowadays ELT approach is more followed, though ETL can also be done in some of the cases where especially for the streaming kind of job, that okay, you extract the data and do some stream processing and then load it. So extract on the go, transform on the go, and then load it to the target. It can be SDFS or some other NoSQL kind of database, right? So I would suggest that there is no such ETL or ELT uh, thought process behind designing pipelines nowadays. The design of the pipelines nowadays are more based on the business requirements and the real time and batch requirements rather than ETL or ELT.
Hmm. Okay. Any so one very naive question maybe from people's point of view, when we are using ETL was basically used before, and now mostly we are using ELT, sorry, yeah, ELT, right? So we are loading in and transforming it. So how does it impact the storage? Because I believe we are also loading the raw data and then transforming and then also storing it somewhere, right?
Right. Good question. I got your question that whether the storage will be a bottleneck in the future, that if you keep on copying the data from one layer to other. So nowadays, the thing is storage is very cheap. If you talk about cloud storage like ADLS or S3 or GCS, so it is very cheap. It's like very cheap, it's in pennies, right? So the thing is, storage is not a bottleneck from the financial aspect of it. So nowadays, if you but at the same time, if you on-premise system, there might be certain bottlenecks. But nowadays, the concept uh, of this or change like removing the storage and compute to different aspect, right? The storage is a different thing and compute is a different thing, because of the object based storage. So previously what used to happen, like a laptop, you have a laptop, you have a hard disk in it, you have a CPU in it, right? If you want to increase the hard disk, you have to put more and more hard disk to this laptop, but there is a limit. You cannot put like 1000 terabyte hard disk in your laptop, right? So similarly, uh, the server also have those kind of limitations. So in those kind of limitations, nowadays object storage comes into being, where the storage part of the servers are separate and the compute part of the servers are separate. So if you want to invest in storage, you only invest in storage. If you want to invest in compute, you invest in compute. So all this, because of the disaggregation of storage and compute, has become very easy to manage, even if we have multiple copies of the same data, though we don't want to make it. But if that's required for data traceability, data archival purpose, data retention purposes, then it's not a big cost to the organization.
Great, great. Probably last few questions. Okay, Rajiv is asking, can you see the question, Swara, or should I dictate?
Yeah, it's written that I have more than 3+ years experience in BI and business analytics using Power BI, Tableau, advanced Excel, but I cannot see after that. He is just, is it okay? Is it possible to learn some more analytical tools like Python or Azure Cloud, Data Factory, Data Lake? Definitely, but it depends on where you want to migrate your career to. Do you want to become a data engineer, or you want to become an advanced or maybe a senior business analytics role in itself? So it all depends on your interest. That okay, if you want to continue with the business analytics, you can learn cloud-based business analytics, like you have already learned Python, Power BI, so you can integrate your knowledge of Power BI with Azure Data Factory, because that is the pipeline aspect of it, right? Data Lake and Spark and something is something kind of a different ball game altogether. Definitely, you can learn it, but you have to get very in depth to do a full time career in data engineering.
Great, great. So probably we'll take the last question, which is from Anubhav, which is, can you explain why Snowflake is getting so popular these days?
It's a very good question, Anubhav. So yes, you must have seen that nowadays a lot of openings and a lot of work is being done on Snowflake. Though all this, whether it's Snowflake, whether it's Databricks, whether it's Cloudera, whether it's any kind of data platform as such, right? So all these are temporary in nature. I mean, temporary. I'm not say temporary. That means today are there, tomorrow they are gone. No, it's not like that. Uh, it's the same like previously there was Orkut, then Facebook came, and then MySpace came, then Facebook came, right? So like the social media platforms are changing, so the data platforms are also changing. So today it is the Snowflake, tomorrow and Databricks, tomorrow it might be something else, right? Who knows? So that's why I would suggest you that if Snowflake is required by your company to work on your project, then you can learn that. It's not harm. But just because Snowflake, you see some jobs and you start learning, so don't deviate yourself by learning hundreds of technologies rather than focusing on the fundamentals, 4 or 5 technologies which I told you. So if you learn SQL, if you know SQL, if you know Spark, if you know programming, any company will take you and they will train you on Snowflake in no time, right? Learning Snowflake is not a big deal, to be frank.
Great, great, great. Okay, I think that's it. Most of the questions have already been answered, and it's really a pleasure to have you on board, Saurav, on the channel. You have answered all the questions, and I really liked the way you answered as well. Even I got so many insights from it. I hope everybody got insights as well. In case you have any other questions, please write down, and we can wind up the session right here, right now. In case you have any other questions, we'll also try to have a poll on LinkedIn maybe after a month or so. In case you still need another session with Saurabh, I'll probably try to get his time again. So that's it for this video. A small announcement which I basically told in the first part of the video. What's the announcement? The announcement is nothing but, as we have already started the live sessions from next Sunday, we will probably be having some live classes, and it's going to be on Power BI. So you can see on the screen, Power BI classes are going to start from 20th of March. at 7 p.m. IST, and it's going to be 6 or 8 hours of classes. So 4 weekends, there will be classes on Power BI. It will be covered from scratch till live projects and all those things. This entire Power BI series might be available on multiple other platforms as well, but on my channel it will be completely free of cost, and anybody who has no knowledge on Power BI can join. So that's all about this particular session, guys. I really uh, enjoyed, and really thank you, Saurav, for joining this session with me. Would you like to tell anything else, or shall we just wind up the call?
No, I would just suggest everyone, whoever is interested in data engineering, to focus on the fundamentals. Don't lose the momentum and the focus. And yes, the career is very good and promising. So get into data engineering.
La- Last question by Anubhav, which can create good views as well. Controversial question: why data scientists are getting more hype than data engineer? I honestly have no answers for that.
Because
Let's
the word
have.
scientist is coming, right? Scientists are always hyped than engineers.
Yes, yes. Yeah, yeah.
Right.
So, okay, that's all about this particular video and particular session. It was a great session with Saurabh. In case you want to follow data engineering, you can definitely follow his channel. You can also follow him on LinkedIn. All his credentials, not credentials, sorry, all his links are provided in the description below. I have just updated the description as well, and I'll definitely push him to upload more and more videos so that you can get more contents on data engineering. That's all about this particular session. See you in the next session. Thank you. Bye bye. And thank you, Saurav.
Thank you. Bye.
Thank you.